All right, vectors. So you've done vectors in physics? No? Some yes, some no? Basic vectors. Okay. Now, if something has a direction and a magnitude, in other words, some sort of measurement with that direction, then it's called a vector. If it just has a magnitude, an amount, then it's called a scalar. So distance, 20 kilometers, we don't know in what direction, it's just a distance, that would be considered a scalar. Or if someone said 15 kilometers per hour, you've got a magnitude there, you've got some sort of measurement, but you don't have a direction, so then it's also just a scalar. But as soon as you would put a direction to it, 20 kilometers west, then that would become a vector. Or 15 kilometers per hour down, then you would all of a sudden have a vector. Okay? So displacement, because it's saying from where you started to where it ended, that would be a vector, and velocity as well. So here we have a list. So what we're going to start with, you are going to go through each of these and decide which ones are scalars, which ones are vectors, and which ones are neither for each of these. First one, scalar. There is no direction to that temperature. What do you think for the second one? Scalar. We're not told which direction it's going, but if we knew which direction, then we would have a vector for this one. Third one. It is a vector because we've got a direction north and we've got a measurement there as well, 5 kilometers per hour. This one, we just have a direction but no speed to it. This one is neither. This one is a vector because we have a direction and a force. Rock has a mass of 5 kilograms. Box has a volume. Car is speeding eastward. Again, this is only a direction. We don't know what its speed is. And there are the last three on the next page. All have a direction and a magnitude, so they are all vectors. So the way that we write a vector is with a straight line and an arrowhead. Sometimes that arrowhead, like in this one here, that arrowhead is in the middle. Sometimes you have the arrowhead on the end. Doesn't really matter. So there we have a position vector. Now with a position vector always starts at the origin. And it's a way of measuring things from the origin to where the point is. So this position vector from O to P, vector A, and vectors are often shown in textbooks with a bold letter. Okay? When you're writing it, it's pretty hard to write in bold while you're taking notes. Often someone will put an arrow over it to show that it's a vector. I seem to remember always making my arrows with only half because it took less time to draw it than if you had to draw the whole arrow. So either will be fine. I'll understand what you mean. Now a column vector here with an x and a y tells you you have to go over in the x direction a certain amount and then up. Almost looks like a matrice. So xy is the position vector where P has the coordinates x comma y. So you can show any point on the on a coordinate plane as a position vector. So if you went from O to A, that would be a position vector, and A was at 6, 3, you could write it as a column vector 6 and 3. So we always put the x on the top and the y on the bottom. So we can write it as lowercase. Sometimes you underline it. I like the little arrow over top. Either way will be fine, but something to show that you're representing a vector. Because when you're writing it, unless you really want to, while you're writing, take extra time to like bold it. Or maybe you have a special, Sharpie that you use for your vectors, so every time you write it, it's like. So if you wanted to find the magnitude of a vector, the magnitude of a vector is shown by its length. And the way that you write it is you sort of put absolute value bars around it. Absolute value bars, did you know technically the meaning of absolute value bars is how far away from 0 that point is? So how far away from 0 is -3? It's 3. It's 3 away. And we learned that absolute value bars were just made negative things positive and kept positive things the same. But really, it is a distance kind of thing. It's saying how far away is that point from 0. So we also use the same kind of notation when we're trying to find the magnitude of a vector. We just find the distance. And if you had the point 6, 3, and you wanted to find out how long that vector is, well, you could make a triangle, and you know this is 6 and this is 3. So the magnitude of OA will just be a squared plus b squared equals c squared, and square root it. So we would get 36 plus 9, square root of 45. Can we simplify square root of 45? There's a 9 in it, so it's 9. So it's 3. Whoa. 3 root 5s. Yes? You wouldn't have to simplify it unless it asked for it to be in simplest form. What's that? Then 3 root 5s.